animation with matrices. Even though large matrices are used for computer animation, you can use a simple matrix to describe many of the motions called transformations that you learned about in geometry. Some of the transformations we'll examine in this lesson are translations, reflections, rotations, and dilations. We can represent triangle ABC or any polygon by the following vertex matrix. So vertex matrix, you put the x-coordinates in one row and the y-coordinates in a second row. And so each of these are the points on that make up the polygon. So you have point A that's -2, 4. And point B that's 0, 6. And point C that's 1, -1. So different kinds of transformations. The first transformation that we can do is a translation. And so a translation is shifting a figure, moving it around. So we've got a point here at -2, 4, and a point at 0, 6, and a point at 1, -1, right? We get a triangle that looks like this. If we want to shift it 3 units to the right and 2 units down, right? We would take each of these points and shift it over 3 and down 2. So we would get a new point here, and a new point here, and a new point here. And so we would get the same triangle but moved over. And so what we're doing is we are adding 3 to the x-coordinate and subtracting 2 from the y-coordinate. And in matrices, the way that we do this is that we add the translation matrix. So if we have this matrix here, and we add 3, 3, 3, -2, -2, -2, you add -2 plus 3, which is going to be 1. 0 plus 3 is going to be 3. 1 plus 3 is going to be 4. 4 minus 2 is 2. 6 minus 2 is 4. -1 minus 2 is -3. So that's how you get this matrix. If you add the original matrix plus the translation matrix, you're going to get the new matrix. And so the original triangle is the pre-image, and the new triangle is the image. So your translation matrix is going to be positive if you're going up or to the right, and it's going to be negative if you're going down or to the left. X and Y. And here you can see a picture that is better than my terrible graph. Much better graph here. So the one in blue is the original pre-image, and then the one in red is the image. Shifted right 3 and down 2. Suppose quadrilateral ABCD with vertices A at -1, 1, B at 4, 0, C at 4, -5, and D at -1, -3. 1, 3 is translated 2 units left and 4 units up. So here is our quadrilateral. So represent the vertices of the quadrilateral as a matrix. So -1, 1, 4, 0, 4, -5, and -1, -3. That's the vertex matrix. You just have put all your x's here, match them up with all your y's here. Now the translation matrix, we want to do 2 units to the left, so we want to subtract 2 from every x, and we want to do 4 units up, so we want to add 4 to every y. Use the translation matrix to find the vertices of A prime, B prime, C prime, D prime, the translated image of the quadrilateral. So add these two together, and so -3, 2, 2, -3, and 5, 4, -1, 1. Add these two matrices together, and that should give us the coordinates of the image. So if I graph this, -3, -3, 1, 2, 3, 4, 5, 2, 2, 3, 4, 2, -1, and -3, 1, you can see that this gives me the same quadrilateral, but shifted 2 units to the left and 4 units up. A prime, B prime, C prime, D prime, and this was A, B, C, D. So that's translations. Translations is just adding the matrix with the X and the Y, however you want to slide or translate the polygon. Or the figure, whatever we're calling it. For reflection and rotation, you are going to multiply the vertex matrix by one of these. I'm not going to make you memorize these. I will give you these. I will give you a chart that looks like this, that tells you the x-axis, the y-axis, and the line, and the matrices on a test. You do not have to memorize these. But so what you're going to do is to reflect over the x-axis, you're going to multiply by this matrix. To reflect over the y-axis, you're going to multiply by this matrix. To reflect over the line y equals x, you're going to multiply by this matrix. You also have the rotation matrices. So for a counterclockwise rotation about the origin of 90 degrees, you're going to multiply by this. 180, you're going to multiply by this. 270, you're going to multiply by this. To create an image that appears to be reflected in a mirror, an animator will use a matrix to reflect an image over the y-axis. Use a reflection matrix to find the coordinates of the vertices of a star reflected in a mirror, the y-axis, if the coordinates of the points connected to create the star are these. So first of all, we need to put our coordinates in a vertex matrix. So -2, 4, -3.5, 4, -4, 5, -4.5, 4, -6, 4, -5, 3, -5, 1, -4, 2, -3, 1, -3, 3. So there's our vertex matrix. Now, in order to reflect this over the y-axis, we're going to need to multiply by this reflection matrix. So -1, 0, 0, 1. We're going to need to multiply by this reflection matrix. -1, 0, 0, 1. And so the reflection matrix needs to go in front of the vertex matrix because we need to, because this one is a 2 by 2 and this one is a 2 by 10. And so remember that the columns of this one and the rows of this one have to be the same. If we put the reflection matrix down here, then we'd have 2 by 10 times 2 by 2, and that wouldn't work. So the reflection matrix has to go in front because matrix multiplication is not commutative. So we put this one here. And then to multiply matrices, we multiply the row of the first matrix by the column of the second matrix. So we're going to multiply -1 times negative 2 plus 0 times 4. Negative 1 times negative 2 is 2. And then we're going to do it for the next column. So negative 1 times negative 3.5 plus 0 times 4. And that's going to be a positive 3.5. And so hopefully you start to notice a pattern. We're going to be multiplying all of the x's by negative 1. And then we're multiplying all the y's by 0, so that's not going to change anything. So the next one would be positive 4. Would be positive 4. And then positive 4.5, positive 6, positive 5, 5, 4, 3, and 3. And so that gives us the first row of the matrix. And then we are going to multiply the second row of the reflection matrix by the first column of the vertex matrix. So we get 0 times negative 2 plus 1 times 4. And that's 0, and that's just equal to 4. And so then we do it for the next column. And so that's 0 times negative 3.5 plus 1 times 4. And that's also 4. And so again, hopefully you notice a pattern that you're going to be multiplying the x by 0, which is going to make it go away, and multiplying the y by 1, which is going to make it stay the same. And so your y's are not going to change. So this gives us the new matrix, wherein all of the x values have switched from negative to positive, and all of the y values have stayed the same, and that ends up being a translation across the y-axis. So now we've got our original vertex matrix here, and we've got our transformed matrix, the reflected matrix, here. And so we can graph these. So we've got one at negative 2 up 4, negative 3.5 up 4, negative 4 up 5, negative 4.5 up 4, negative 6 up 4, 5, 6 up 4, negative 5, 3, negative 5, 1, negative 4, 2, negative 3, 1, and negative 3, 3. And so it gives us this star shape. And so then to reflect this over the y-axis, right, we use our new matrix. And so all of our x values go from negative to positive. So 2 up 4, 3.5, 4, 4, 5, 4.5, 4, 6, 4, 5, 3, 3, 5, 1, 4, 2, 3, 1, and 3, 3. And so that gives us this figure, which is reflected over the y-axis. Suppose the figure is animated to spin around a certain point. Numerous rotation images would be necessary to make a smooth movement image. If the image has key points at 1, 1, negative 1, 4, negative 2, 4, and negative 2, 3, and the rotation is about the origin, find location of these points at the 90, 180, and 270 counterclockwise rotations. So our vertex matrix, 1, 1, negative 1, 4, negative 2, 4, and negative 2, 3. And we want to rotate it about the origin, 90, 180, and 270 degrees counterclockwise. So we're going to multiply by the rotation matrix. And so if we go back here, the 1 for 90 degrees, 0, -1, 1, 0. 0, -1, 1, 0. And again, you have to put the rotation matrix out front because this is a 2 by 2 and this is a 2 by 4. If you put it at the end, it's not going to work. And so then we just multiply these two matrices. So we multiply the row of this one by the column of this one. 0 times 1 plus -1 times 1. And so that's going to be -1. And so you're always multiplying the x by 0. And you're going to multiply the y by -1. So the next one would be -4, 4, and 3. And then we are going to take the second matrix, the second row of the matrix, and multiply it by each column. So 1 times 1 plus 0 times 1 is going to be 1. And so you're multiplying the x by 1 and the y by 0. So the x's, you're going to take the x's, and they're just going to stay the same. So it's going to be -1, -2, -2. And so this gives us our matrix for the coordinates rotated 90 degrees about the origin. If we're going to do it for 180, so this was 90 degrees, if we're going to do it for 180, 4, -2, 4, -2, 3, the matrix for 180 is -1, 0, 0, -1. So -1, 0, 0, -1. So we're going to multiply the x by -1 and the y by 0 for that first row. So all of the x's are going to switch signs. And then for the second row, we're going to multiply the x by 0 and the y by -1. So the x's go away and the y's get multiplied. They switch signs. -4, -4, -3. And then for 270 degrees, 1, 2, -1, 4. I'm going to take that same vertex matrix, and we are going to multiply it by the rotation matrix for 270, which is this one, 0, 1, -1, 0. And so when we multiply the row by the column, we multiply the x by 0, we multiply the y by 1. So the y's just end up here, the way that it is. And then here, we multiply the x's by -1 and the y by 0. And so we get the x's, but they switch signs. They're supposed to be negatives in that one. And if you graph them, try graphing them on your own, but it looks like this. Rotated 90, 180, and 270 degrees around the origin. A dilation changes the size of a figure, producing a similar figure. To produce a dilation, multiply the vertex matrix by a constant. This is super easy. So it's the reflection and the rotation matrices that are tricky because that involves matrix multiplication. Translation only involves adding matrices, which is easy, and dilation involves multiplying by a scalar. So a trapezoid has vertices at -4, 1, 1, 4, 7, 0, and -3, -6. And hey, we'll go ahead and graph that. 1, 4, 3, 4, 5, 6, 7, and -3, 2, 3, 6. So here is the trapezoid. And so we are going to find the coordinates. This was L, M, N, and P. We're going to find the coordinates of the image L prime, M prime, N prime, P prime for a scale factor of 0.5. And so all that means is that we just multiply the vertex matrix by 0.5. So this is -2, this is 0.5, 0.5, 2, 3.5, 0, -1.5, -3. So everything just gets multiplied by 0.5. And then if we graph this, -2, 0.5, 0.5, 2, 3.50, and -1.5, -3. That's L prime, M prime, N prime, P prime. So it gets us a similar trapezoid that is half the size. Alright, so dilations and translations, pretty easy. Reflections and rotations, a little bit trickier, but I will give you the matrices. You just have to remember how to multiply them. And that is important that you put the transformation matrix out front. Alright, one more section of chapter 2 left after this.